Hey guys, what's up? This is Madan Sir here again, and I'm with another video for you. And this time, like most of you may be aware that I'm doing electrochemistry these days. So this is going to be probably the fifth, sixth, lecture of electrochemistry. And in this video, I'll be, discussing about what are some of the basic terms related to, electrolytic conductivity. And let me introduce to all those terms to you so that you already have, a mind made up. The first thing I'll be talking about, the resistance, conductance. Specific conductance, also called conductivity. And then I'll be coming to finally molar conductivity. And if things related to molar conductivity gets done, then I will, let you know about, limiting molar conductivity. So these are some of the topic of, of today's videos. I'm, concerned to make all these together in this particular video. First thing, I feel like I must tell you what is an electrolyte. I'm talking about the very basic things. Electrolyte. So an electrolyte, is an ionic compound that dissociates into ion. That dissociates into ions. So ions. It has mainly two types. It's called strong and weak. So let me write it first and then I will explain you. Strong electrolyte. Completely dissociates into ions. Completely dissociates into ions, while the other one is called weak electrolyte. And this one incompletely dissociates. Incompletely dissociates into ions. So let me tell you the facts about the electrolyte. You know what? These are chemical species which breaks into ions when you dissolve them into a certain solvent. And the most common solvent we always have in our mind is nothing but water. So when you put something in water and if it breaks into ions, it's called electrolyte. And if it dissociates completely into ions, entirely separates into ions, called strong. The example can be like, like HCl is a strong electrolyte. Like NaCl is a strong electrolyte. Let's talk about acetic acid. This is a weak electrolyte. So what that means? That this compound do not get completely ionized, therefore it produces ions in less amount, but this one these two undergo 100% ionization. So I must write it like 100% ionization, but this one of course less than 100% ionization. I hope you have understand this very small basic topic, right? Now the question is, we started with electrolytic conductance. So let me take you through some of the basic terms related to electrolytic conductance. So the next thing is basic terms about electrolyte conductance. So this is what this video is mainly concerned about. So what I'll be doing, I'll be talking about, first I'll be talking about resistance, then I'll be talking about conductance, and then third one is going to be, specific resistivity, and the fourth one is going to be conductivity, and then the last one will be molar conductivity. So this is the concern of this particular video, right? If you remember very last video where I told you about the solid and electrolytic conductance, what are their differences, how you can easily understand each and everything about. So this was the very next topic coming up, so that's why I'm doing right now. Let's talk one by one here, right? Talk about them one by one. What resistance is, you know that, but since I'm making everything, even though it's a little one, but I'm still interested to make you go through. So resistance is a property of wire to resist. If you have a problem with resist, to stop flow of charge. So what charge here? I'm talking about current. Flow of charge through it. Right? So what is resistance? It's a property of almost everything where the current is not supposed to flow because of this property. Now I've already told you what are the reasons in solid conductance and an electrolyte solution. The thing is that it is represented by R. This is represented by R, and its SI unit is ohm. It's also something like this is also made. I'm not very good at drawing, so I hope you forgive me for that. So R is the symbol, its SI unit is ohm, and this is how it's as a symbol is taken here. Let's talk about the conductance here. So I'm talking about, this was the first one, so let's talk about the second one. This is conductance. Conductance is defined as inverse of resistance. So what that means? Conductance is defined as the reciprocal of resistance. So, and in case you go with the formula, conductance is represented by G. In NCERT it's represented by G, but you can also write it with C. So I'm writing both. Right, so C is also a symbol. What G is equal to going to be, if you take a look at this one, this is going to be 1 upon R. So what's the formula going to be? This going to be, this is its unit going to be ohm inverse. Sometimes it's written as MHO, mo. What is that? I don't know who made all this, but sometimes this is inverted. But its SI unit is Simon. Some people call it Siemens. I don't know why. So Simon, which is also represented as capital S. So let me repeat back the whole thing here. Conductance is defined as inverse of the resistance. So G, or you call it C, is equal to 1 by R, and that's equal to ohm inverse. Sometimes we can written as this one, MHO, mo. Its SI unit is Siemens. These are not SI unit. Right? So with that, I hope you have understand what conductance means here. Let's get back to the third one here. Defined as reciprocal of this is defined as magnitude of resistance magnitude of resistance of a wire of 1 meter length and have 1 meter square area of cross section. What that mean? Resistivity is a constant of proportionality. So what that mean? Let me take you a certain example. Suppose this is your wire here, and this is the thickness here. Let's make this length of the wire 1 meter. This length is 1 meter. So what I'm doing here, L equal to 1 meter, and this is your area. This one, particularly this area is your area. So A is equal to, of course, pi r square, which is going to be meter square, right? So if we come back to the resistivity, this is represented as rho. So rho is equal to, you have an original formula, R equal to rho into L by A, where rho is the constant of proportionality called resistivity, L is the length of the wire, and A is the area of the cross section. So what will be? This is going to be like RA upon L. You understand? Hopefully. So let's talk about the unit here. Resistance unit is ohm. Its unit is ohm. Area unit is meter square, and length unit is meter. So what it's going to be? You're going to have 1 meter is cancelled by other, so this is going to be ohm meter, right? This is going to be ohm meter. So this is also the SI unit. So SI unit of rho is ohm meter. How this has come? Yeah, hopefully you have understand. So this is the thing here. Now let's get back to the next thing, and what we have is conductivity. So talk about conductivity. Conductivity is represented by K, also called kappa. Don't call it, something like katappa or whatever, I don't know. These terms are really popular these days. So this is just kappa, or you call it kappa. I call it straightway in kappa, but you can remember yourself calling itself katappa or whatever. Though I hardly know about katappa. I just remember there is something, a character of a movie, but I don't know anything else about the character. I haven't seen that. So conductivity is defined as reciprocal of resistivity. Reciprocal of resistivity. So what that mean? K is equal to 1 by rho. Right? Now let's put some unit here. So this is going to be 1 by, rho was equal to R into A by L. Right? So this is going to be like, 1 by R into L by A. I hope you are understanding. So let's get to the unit here. The unit of R is ohm, into unit of length is meter, and unit of area is meter square. Unit of, this is going to be meter square. So what we are going to have here, this is going to be like, ohm inverse, meter inverse. Ohm inverse, meter inverse. However, SI unit is Simon. You remember that? Simon meter, Simon per meter. You can also use it like Simon per centimeter. Why? Because we are talking about electrolytic solution. and the ions are present in very small area, and it's hardly going to be in meter. I don't think it's going to be in meter, so we need to be using centimeter as a measured unit here. So this is going to be very common, Simon per centimeter, and not the Simon per meter. So I hope you have come to the conclusion what I was interested to let you know through. Molar conductivity right now. This is something important. Molar conductivity. Let me define it first and then I will discuss. Conductance of all the ions produced, all the ions present in a volume, that contain 1 mole of electrolyte. 1 mole of electrolyte. Let me repeat back, because this definition is very, very important for all of you, those who are having board exam coming 2020. So conductance of all the ions that is present in 1 mole per liter of a electrolyte solution. So it is basically the definition right here. Molar conductivity is represented by lambda. This is something in Greek language. So represented by lambda, and lambda is equal to K into 1000 by molarity. But if you if you find out C written there, don't get surprised, because where K is conductivity, and M is the molarity of the electrolyte solution. Molarity of electrolyte solution. So C is also representing the molar conductivity here. Now, what we need to do, we need to find out how this relation is coming out to be. So what I'm going to do is to explain you right here. What molarity is defined as number of moles upon volume of solution in liter, right? So what you do is if number of moles is 1, because we are talking about 1 mole of electrolyte. So this is going to be 1 upon volume in liter. And in case this is not in liter, you have to multiply it by 1000. So can we write it like 1000 here, but this time it's going to be in milliliter. Volume in milliliter. So you do know probably what I'm saying. So that is the reason I've used 1000 here. So K into 1000 upon C, or K into 1000 upon M. Now let's change a little bit here. Molar conductivity and its unit. The unit is going to be SI unit. So talk about the unit of the molar conductivity. The SI unit is going to be Simon centimeter square per mole. So what you can also write, in short, Simon centimeter square per mole. If you are interested to make this in meter, you can write it like Simon meter square per mole. So this is what the unit of molar conductivity. This is very, very important, because they might ask you what is the unit of molar conductivity, if they are interested in giving something very simple coming out to be. I hope you have understand what this molar conductivity is. Let me wind this video right here, and I need to be a little bit formal with you. So that was the introductory part of the electrolytic conductance. In the coming section, I will be talking about what is cell constant, what is the conductivity cell, and then we'll be coming to the limiting molar conductivity. Right? So that's it. I just hope I have made you, go through something very simple and you are just, happy with that. In case you are, what you need to do, you just take care of self, take care of other also. And one very important thing is keep, letting me know, because there's nothing you have to be hesitated about. We are doing things on online way, method. So even if you are critical, that's okay. Anyway, thanks for watching.